You are most welcome to our today's class in mathematics, and I just want to introduce a question that I've actually been given by a student from a topic called vectors 2. And this is the question. You've been told that there is a Cartesian plane that I've just drawn, and of course this Cartesian plane is given in the question. And you're told that this is the origin O, and of course this is going to be our y-axis, and this will obviously become our x-axis. And you see, a line has been drawn. This line represents a vector. And you've been told that this is point P and this is point Q of that vector. So the vector becomes PQ. I'm told that at this point, we have 3. Then at this point as well, we have 3. So at this point P, the value of x is 3 and the value of y is 3. So the coordinate of P becomes 3, 3. 3, the value of x, and again 3, the value of y. I've actually been told that at this point Q, the value of x is 8 and the value of y is 5. So the coordinate of Q is 8, 5. So the value of x is 8 and the value of y at that point Q is 5. So the first question was asking us to get vector PQ. If someone tells you to get vector PQ, please just say vector PQ is able to get obtained by just taking Q minus P. The opposite can give you vector PQ. So I have to actually consider moving from point P to Q, and for me to get that vector PQ, I just take Q minus P. So what is Q in terms of the coordinate at that point? X is 8 and y is 5. I'll write it as a column vector. Correct? Then I say less. What is P? In terms of the coordinate of P, I'll write 3, 3. At the end of the day, I'm going to have vector PQ as 5, 2. Why 5, 2? I'll just say 8 less 3. That gives me 5. Then 5 less 3. That gives me 2. So vector PQ written as a column vector is 5, 2. And that now becomes our vector PQ. Then the question proceeds and then tells us that if someone takes KA, then adds to HB, the answer must be equal to vector PQ. If I take KA plus HB, I should get PQ. They're telling us that let's take K and H to be our constants. So a constant K times vector A plus a constant H times vector B. The answer must be equal to vector PQ. Then, how do I then get the values of these two constants, which are K and H? I've actually been told that vector A is equivalent to 3, negative 1. And I've been told that vector B is equivalent to negative 1, 4. So if those two vectors are given, then it is very easier for us to get the constants K and H if we have PQ as the vector obtained in part 1 of that question. So the Roman 2 expects us to get the values of the constants K and H. If vector A is given and vector B is given, and as well, vector PQ is already obtained in the first part of that question. So we shall just proceed. We shall just say K, the constant that we're actually looking for in terms of its value, into A. And A is 3, negative 1. Then plus H, our other constant, into B. And our B is negative 1, 4. The answer must be equal to PQ. And our PQ is 5, 2 as a column vector. What have I done? I've gone to the question given in the question. I have actually gotten the constants K and H still remaining in the question, but where there is A and B as our vectors given in the question, I do what you call a substitution by 3, negative 1 and negative 1, 4. So I want to proceed, then get the values of k and h as our constants in the question. I'll open the brackets. I'll just say k times 3, I'll get 3k, that's correct, plus, then h times negative 1, I'll get negative 1h. The answer must be equal to 5. I've actually decided to do first the first part of that expression in terms of just saying k times 3, I'll get 3k, then h times negative 1, I'll get negative 1h. So it is plus negative 1h. So k times 3, let me just use a different pen with a different color. So k times 3, I'll get 3k, then plus, that is it. Then h times negative 1, I'll get negative 1h. That must be equal to 5. Now the second part, I'll come here and say k times negative 1, I'll get negative 1k plus, that's correct. Then h times 4, I'll get 4h. The answer must be equal to 2. This one here. Now let's proceed. We'll just now come and solve these equations simultaneously and be able to get the values of the constants given as k and h. We shall proceed. We shall use 3 and negative 1. What method am I using? I'm using elimination method. So I'll put here negative 1, then put here 3. So just interchange those coefficients of k, or you can decide to use the coefficients of h by doing what you call uninterchanging, then multiplying all through by that value. So I'll start. Negative 1 times 3k, I'll get negative 3k plus negative 1 times negative 1h, I'll say plus just h, because negative 1 times negative 1 is just positive, so it will just be positive 1h. Then negative 1 times 5, I'll get negative 5. I'll begin again from this end. 3 times negative 1k, I'll get negative 3k plus 3 times 4h, I'll get 12h. Then 3 times 2, I'll get 6. I'm going to now subtract going downwards. We say different signs you add, same signs you subtract. Now, minus 3 minus 3, that gives us 0k. So k has been eliminated. That's why the method is called elimination method. Then plus, then 1 minus 12, that gives us minus 11h. That must be equal to minus 5 minus 6, that gives us minus 11. So we shall say minus 11 minus 11. This and this will disappear. So our h is 11 divided by 11, that is 1. So our h is 1. Now, if our h is 1, then you can pick any of these two equations, the two simultaneous equations. Just pick one, then be able to substitute where there is h by 1 for us to get k. I'll pick the first one, for example. So I'll just come here and pick the first equation. So I'll have 3k plus negative 1h. The answer must be equal to 5. Correct? Then I know h is 1. So I'll just come here and say 3k plus negative 1 into, I don't again end up writing that h. I substitute that h with 1. Then that answer must be equal to 5. So it actually proceeds and then becomes 3k plus 1, then times negative 1, that gives us minus 1. That must be equal to 5. Let's take one on this other side. So we shall have 3k is equal to 5 plus 1. Because if a negative value crosses the equal sign, it becomes a positive value. So we shall then end up having 3k is equal to 6. If we divide both sides by 3, then we shall end up having our k as 2. So that means k is 2 and h is 1. So those are the values that you are supposed to have gotten if you have to do this question in an examination given to you by the examiner. So this is a question that came in the Kenya Certificate of Secondary Education examination for this year, and the students were supposed to have gotten this as their answers. Thank you so much, and let's meet in our next lesson.